Last time we almost done with the chapter 11, except that there is a data carrier, the array of object and object of array. We did not finish. That's okay. Today we are going to complete it, okay? And then, but we will not get started from that chapter 11. We'll get started for chapter 12. And that topic in chapter 11 actually can belong to chapter 12 as well. So don't worry, okay? We actually still follow a really good order. Just that the chapter 11 is a little bit too long. So today we are on class to class relationship. So chapter 11 is talking about a single class design and creating object. That is the purpose of a single class design. This week we talk about class to class relationship. So here we have a class. There's another class, or there may be an object relationship to other object. Okay, these are class to class relationship, object to object relationship. So chapter 11 focuses on a single class, single object. Chapter 12 focuses on multiple classes, multiple objects. Okay, so that's what these two chapters are about. Okay, so in this chapter, the College Board curriculum actually is not a lot. Okay, College Board doesn't have a lot of material in here because College Board take away the inheritance and polymorphism. So basically, the class-to-class relationship have been reduced to minimum. So here only passing and returning reference type, okay, and then instance method, class methods, and keyword. Only these three topics. That's not really not enough. Okay, so we actually add more topic. For example, class design, data encapsulation in immutable classes. This one was in the previous curriculum, 2024 curriculum, but now I'm not sure 26 will test this one or not. Okay, but we are still teaching it. And then this one is a standard knowledge you need to learn. Okay, and we also talk about object-oriented thinking. So these are the chapters that we want to cover, the topic we want to cover. A little bit more than what College Board would require. But not totally not the whole object-oriented programming. Okay, still not the whole things. So we'll also talk about how to design a good class. What is a relationship? What has a relationship? But this is a relationship no longer in AP. Okay, it was 2 years ago. Okay, but no longer. Super still very important, but also not testing anymore. And then big integer, big decimal. This one also was a AP topic, but now no longer an AP topic. Okay, but these different topics, we will put them into AP CSB, the second course. Okay, starting in November, we will put it into there, emphasize in there. Okay, but anyway. Okay, so right here, this chapter, this is the whole thing, all of the topic that will be covered by object-oriented programming, inheritance and polymorphism. These two parts, AP no longer takes it. It was last year, okay, so last year is still in the AP curriculum, but this one was taken away. So today's what we will talk about is this visibility part, encapsulation part. This has a relationship part. These three, okay, these are three topics we will talk about today. But this chart is very important, give you the idea of what is the total concept of object-oriented programming. So object-oriented programming, as I said before, is a tool to manage your object, your classes, your resource, that program developed by other people. Okay. You can also build your own classes for reusable purpose and for future use. So this one still very important. I would say Java is the best language to teach OOP, okay? That's why we teach Java before C++. Java is the best language for OOP. It carries the most features that object-oriented programming would need. So learning object-oriented programming using Java is very important. It is the beginning step in programming, okay? So that's why this Java language is still in APCSA. Even though you want to learn Python, you want to learn C++, your OOP still need to come from this APCSA course, okay? Okay, anyway, these are the topic. Now, next one, we are going to talk about, this one's static members. Static member, this one, I think that the last time we talked about it already for the static members, for the static variable and the static method. Okay, static variable for share variable, static method for share utility purpose. Okay. So that one I think we covered. We don't repeat. So today we are going to get started with the data encapsulation. Okay. Data encapsulation. So let's talk about this idea, data encapsulation. No, not here. Okay, anyway. So first, let's talk about what is data encapsulation. So here, let's talk about data encapsulation. Okay, to learn data encapsulation, first you need to know the idea of capsule, right? What is capsule? Capsule is a protector, right? Literally is a protector. So when we talk about capsule, time capsule, subcapsule, that actually is a thing that isolate your something important to the environment, right? So that's actually it's called capsule. So basically, for example, like you have a medicine, right? You may have a medicine, and then that medicine look like this. So you have some sort of gel or something that protecting your medicine inside. So that's called capsule. So from outside, so let's assume that this medicine is for blood pressure control. Okay. And then you don't need to know about what's inside. You just know about this medicine is, let's assume that it's called a beta blocker. That will block some kind of that's actually help your blood pressure control, right? Let's assume that's a beta blocker. So what you know is the function, the functionality of the capsule. And then from outside, you know it's actually blue and maybe blue and white. That's the only thing that you know. As for the inside, what the ingredient? Inside ingredient, you have no idea. So no idea for the inside ingredient. Okay, so this kind of things we call it encapsulation. You put something inside and you protect it and you don't want other people to know it. That's called encapsulation. So data encapsulation means that you want to protect your data and don't want people to destroy it. Now we call it data encapsulation. So far, okay? Any questions so far?
No.
No? So Harrison, what is data encapsulation?
To like surround like the data to like protect it.
Okay. So that actually is called data encapsulation, okay? And then there's some other ideas called data hiding, information hiding, okay? So these three ideas actually not the same, not exactly the same. They are similar, but they are not exactly the same. One moment, okay? My keyboard is a little bit bizarre. So this is written data encapsulation, information hiding, and the data abstraction. These three terms are similar but not the same. Okay, first idea is encapsulation. So we talked about it already. It actually is like putting your data like a capsule that actually we know. Okay, this one, let me show you the diagram. I did not have this picture in my slides, so I posted it right here. That's data encapsulation. And then information hiding, just talking about the hiding part. Okay, it doesn't talk about the talking about the protection part. So information hiding is have some overlap with the data encapsulation, but not the same, not exactly the same, because you may have information hide but not encapsulated. You may have data encapsulation, but you don't have the data hiding. For example, your state available or some value that's public, you may not hide it, you may share with it. So data encapsulation just means that you encapsulate, but that means that you hide information. Same thing, you hide the information doesn't that means that you put it into the capsule. Okay, so these are two terms slightly different. And then data abstraction usually is using a concept to enclose something. So data encapsulation is part of the data abstraction. And the information is also part of it. Okay, so this data abstraction is a bigger term. So data encapsulation, you can use data abstraction, you can use an array. Array is a data abstraction. Class is a data abstraction, string is a data abstraction. They are all data abstractions. Okay. But encapsulation is used for class primarily. Okay. So that term is a little bit different. Okay, these are a little bit conceptual, and then in the multiple choice problems, they may ask you the difference of these. Okay, so that's why I emphasize right here. Now, we have enough of the theory. Now let's go back to Duquet. Okay, then what really is data encapsulation feature in Java? Okay, so let's go back to look at our. Let me see. One moment. Let's create a class called student. I'll put it simple, a little bit simple, okay? So let's build a class right here. So we do have a string name, okay? And then we may have integer age, okay? We may have double GPA, right? And then we have a student constructor. Here you can use name or n. Okay, usually I use n because I don't want to have the same variable name here and here. Okay, and then you need to use this. I try to avoid that. And then you have integer age and double GPA. Okay, and then your name equals n, your age equals a, and then your GPA equals g. Okay, so I just try to come up with the class quickly. Okay. And then to string function. Okay, so pathing string to string. Okay, so this one complete the so-called to string function. Okay, so we can use it. So that's write a test student class. Sorry. So you declare a student as a declare a student as a student that is actually called area. Okay, area. So area equals new student area 14 3.8. Okay, and then you do system.out.print line area.name system.out.print line area.age. Too many types. Sorry. Okay, anyway, that's wrong. So it print out successfully, but the problem is like here, you actually print out the name, print out the age. Also, you assign a new name to the name. So basically, this test student class modify the object in the student class. This is okay for normal case, but sometimes some other people may be able to change your name or your age or your GPA or sometimes change your bank account balance using the outside program. So we don't like this. We don't like this. So we want to have some protection. So to make it to have that protection, we actually can put these as let's put it as a private. So if we put it as a private, then these three variables can be seen only in the same class. So only same class, only same class. Private means only same class. Now you can multiply the variable. If it is in different class, that you cannot. Okay. So this okay so far. But if you go to the test student here, you compile, it is wrong because you cannot get the name, get the age right now because it's different class. So this doesn't work. Is that okay?
Yeah.
So this keep a protection of if the program is in the same class, it will work. But if we do copy and then put the main function in the same class, then it is okay. Yes, this is okay because it's the same class. So self-class tester private variable can still be used. You test from here, it will work. But you test from here, it doesn't work because it's different class. Is that okay?
Yeah.
So private means private to himself, private to the set class. Okay, private to the same class. Okay. Now there's a problem. Okay, so you cannot get this name, get this age, you cannot modify the name. So how can we modify it? So that's why we need a getter and setter. So now let's put a getter in. So that's why the function name I always call it get name, get age. Okay, so these are three getter functions. Let's put the setter function as well. Okay. And then go back to here, you don't have the that name, but you can use that get name. And use getter and setter to make it wrong. Okay. And that actually is fine. So encapsulation means that you put the ingredient, your variable in there, your function in there, and then you can only access your data using the getter and setter. And usually these getter and setter are public. Okay, public means that it's shared for other people. Okay, so let's assume that if you do change this getter and setter, that's actually put it as private. Then if you get it as a private, then problem come again. Your get name will no longer work because the test student cannot get that function. Is that okay?
Yeah.
Yeah.
So basically that's the problem. So private means you, I'm sorry, I just changed the same name. Okay, I'm sorry. So you actually have to make the function public. So public means that you can share with everybody. Private means that only your class can access to it. Okay. And this kind of the feature, we call it visibility. Where can you see the data visibility? Where can you see the data? Okay, then that's to look at the visibility levels. This one in previous chapter, let's look at the visibility levels. So there are 4 visibility level: public, protected, default, and private. Okay, let's talk about private first. So private, no problem. It is here only the same class you can see. So private is the same class. So private, usually before the variable, you write a private. Okay, that's actually private. Default, you write nothing, write nothing. So default, if you declare the integer age, that actually is default. Okay, that actually default. But default, who can see is the same package you can see. So what do I mean by same package? Same package means that you have test student and student, but in fact, if you look at the hard disk, they are in the same folder. They are in the same chapter 12 folder. So right here, you do see student and test student. So these two in the same folder, we call it in the same package. So if you don't write anything, same package you can see it. Is that okay?
Yeah.
Okay, that's the second level. Third level called protected. Protected means that only your children can see. Your children or your parents can see. Okay, what does that mean? That means subclass can see. So for example, if I do make a class called graduate student, and this graduate student extends student. So graduate student is one kind of the student. Okay, it's one kind of student. Okay, this we call it inheritance. So inheritance is no longer tested in AP. But here we just want to give you the idea of what protected is. So graduate student, stay student, and then you have the name, you have the age, you have the so-called GPA, but you may have another one called degree. Okay, that's actually local condition. So you have the graduate student, and you can take in string, name, integer age, double GPA, and string degree. Okay. And you call the constructor of the student, so it calls super name, age, and GPA. Okay, this one is inheritance and not tested in AP anymore. Okay, but anyway, what I want to say is that graduate student is one kind of student. You will take over the property of student. So this is the name, age, and GPA. They are the property of student, so that's fine. But right here, degree is a new property. So you write this is okay. Now there is also a so-called toString function. So you can override a toString function. So let's do this. Let's do copy string toString. I try to be short. Okay, I'm sorry. Just give you the idea of when you write a child class, what will happen. Okay, I call it G student. Okay. So put your name, age, GPA, and you do it. Okay, now we are done with this. Okay, so these are three, as you can see, they are private. They are private, so you cannot see the data. Okay, you cannot see the data. But right here, let's do one thing. So let's go back to student. If it is not private, let's change it to protected. Let's change it protected, then your graduate student can see it now. Because you are the subclass available, you will be able to see. No need to be the same class because it's a subclass. So subclass in BlueJ, you do show this kind of white arrow. That means graduate student is one kind of student. It's okay?
Yeah.
That's why I like this package view by the BlueJ. It shows you the class-to-class relationship well. Any questions so far?
No.
No.
Okay, so this one you change it to protected, that's fine, okay, but we want to keep it as a private, okay? Here I just make an example for it. So in case that you are private and your child class cannot see it, what can you do? Then you have to do, then you go to your graduate student, then you have to do using the get name. Okay, you have to use the get function because get are public. You will be able to see it. Okay. Okay, so that's actually what these different levels are. Okay. Then the next level is public. Public, everyone can see. Everyone can see. So this one nothing to talk about. Okay, it's actually pretty straightforward. So here to tell you the public protected default private. Public sometimes write these, okay. Protected sometimes use a tilde. Private sometimes use a minus. When you are in the UML, that's the mark they use. Default write nothing. Is that okay? So public, you can see from different package. And then protected, you can see from different package or the same package. But I'm sorry, you can see from the subclass. Okay. And default, you can see it only in the same package. Okay, default. And then private, you have to only see by the same class. Okay, these are the basic rules that govern this private public protected. Okay. So that's the tool that we use to encapsulate the data. Okay, that's the tool that we use to encapsulate the data. Now, next concept. So, when we talk about data encapsulation, usually it's private data, public method. Private data, public method. Usually, combining private data, public method, we call it data encapsulation. So your data usually put it as a private, and then keep the methods that can be accessed by the public. We call it data encapsulation. Is that okay so far?
Yeah.
And sometimes there's a violation, say you have public available, then you put your data to be risky, but sometimes it's more convenient. So whether you like the convenience or you like the security, up to you, okay, up to you. The programming language provide you the feature, that means that you need to use a private all the way. That means that, okay. So sometimes you may have a secret method that you don't want other people to call it. Then you make it private, but that's both these cases are not usual. Usual cases, private data, public methods. Okay. Or state available, we talked about it already. I'm sorry, I'm a little bit off. Protected is using sharp sign, okay. Default using, this is actually default using the tilde, I'm sorry. These are the UML mark. Okay, I don't want to spend too much time on this visibility part, okay. Just give you the concept. So here, this one, you have a circle, but you do see a minus sign there. Means that these are private data. Here you have a plus, this means it's a public method. Is that okay?
Yeah.
And your constructor are usually just public. Because constructor is used to build your object. So there's no reason that your constructor is private. Okay, there's no reason your constructor is private. So this we call it UML, Unified Modeling Language. So when you read this, you will see the public data or methods and data type, okay? Okay, that's actually the so-called data encapsulation. Now let's look at another topic. Another topic that's called scope. Okay, scope. So here you do have available. These are instance available. So instance variable, you can, as long as the object created, the data is there. This we call it instance variable, okay? But you may have a static integer number of student. Okay, so whenever you create a student, your number of student increase, right? So this one is a share variable. This is a share variable. Oh, here I have H for R, I'm sorry. But this variable is available even no object created. So you have a class, they already have this variable number of students that equals 0. So when you create an object, this number increase to 1. You create a second object, it increases to 2. But if there is no object, this variable already exists. Now we call it static variable. It's static, it's always there. But let's look at the other variables such as the name, age, and the GPA. Because name, age, and GPA belong to a single student. So when you create a class, is there the name variable? No, there's no. Is there the age? There's no age. Is there a GPA? No, there's no GPA because you need to wait until you create the object. Then the object comes with the name, age, and GPA. So these variables are available only when the object is created. Only when you do new, then there's that variable. This number of students is always there because no student, the number of students is 0. Is that okay so far?
Yeah.
Okay. Because of these, can you do this? Can you do? Can you do this? It is private, but we use a static function to access it. Jiang, is that okay or not?
Oh, yeah.
No, it's not.
Oh, wait. Oh, yeah.
It's not because what?
Because name's not declared.
Name declare. Name is here.
Oh, wait. Oh, because it's static, I think.
What?
Wait, I'm not sure, but I think it's because it's static.
There's no static. It's private, but no static.
No, I mean on the main function.
But why main function static doesn't work?
I don't know. Probably.
What is the variable name? What kind of variable this one is?
String.
No, that's not what I'm asking for. String
Private.
is data type. I'm talking about what type of the variable this one is. It is an instance variable. Instance variable means whose name this one is. Who does this name belong to? Any object that owns this name.
Student class.
Student class doesn't own it.
The instance of student class.
Instance of student, but which instance right now? Which object?
Arial.
No, Arial has Arial.name.
Oh, wait.
This is a name. So this doesn't work because it belongs to nobody. Okay, so basically, static function cannot use instance variable. So here you have the name, but you use name equal time. This is wrong because then whose name it is, you don't know, and you haven't created an object. So if you create an object, say Houston area, so area has a name. This is okay because this one belong to it. This name belong to area, but this name here belong to who? Nobody. Nobody. Then this doesn't work because you cannot use it. Is that okay?
Yeah.
So instant variable cannot be. So that's why static function always cannot access the instance variable. But instant function access the static variable okay because static variable is always there. So right here, let's assume that you actually your function set. Let's assume that you have toString right here. You actually put the system about the green line, your number of student. Is that okay? Yes, this one is okay. Because this toString function is a function owned by an object. And this variable right here, number of students right here is belong to class. So this one is always there, even you do not create an object, is already there. So if you create an object and that object asks for the number of students, you will still be able to access it. So static function can only access static variable. While instance object, instance function can access both static and non-static. Is that okay so far?
Yeah.
This we call it scope. Keep this in mind. Static means that the data is always there when the class is created. While instance one, the data is not always there. The data exists only when you create a new object. Say you had a student area, then area has a name, area has an age, area has a GPA. So if you do not create areas object, then there's no areas name, no areas age, no areas GPA. But the number of students always there, even number of students is 0, but the variable is still there. So basically your array length. You create an array, you already got the array length. So this one is a static variable. Even though you have 0 array object, you still have the length. Is that okay? And string.length function, string.length is actually a static a function, an instant function, but that one will also fetch the length. Is that okay so far?
Yeah.
Okay, anyway, this I just try to explain to you what is static, what is instance variable, okay? Okay, so this part is the scope of the variables and visibility. Probably up to here, okay, we don't want to go too deep. These are very conceptual, so that's called lifetime scope. Okay. Lifetime scope means that when will be available, be accessible. You have to take care of static, non-static, private, non-private. Also, where the variable be declared. It is a loop variable, or it is a functional variable, or it is a global variable. Those are topic when actually lifetime and scope. So there's a concept called binding. So binding happens when you have an integer a equals 3. Means that this memory location should A put a 3 in there. And this memory location that's assumed is FBA2. That's bind your A with the variable edges. So it may happen that you have a main function, there is an A variable. But later you call a F function, and F function have another A variable. Then this A is different from this A. These two A are different. Green A and red A are different. Then we call it binding, which is the scope of that variable when it is available. Okay, that's called binding. Okay, anyway, we shortly go through these. Yeah, a little bit too much for the slices. This concept, we already explained it already. Okay, this one, let's try this one. So this one right here, we do have a test student, we have the graduate student. This one, let's create test student array. We're going to talk about many students, not just one student. Let me put it right here. So sometimes there may be more than one student. So you say student array student list equals new student 4. So this one create an array of 4 students. Then you do system.out.print line student list. What will happen is you cannot print anything. You print a bracket L student. So this bracket means that it's an array of student type at this location. Is that okay? So far, okay?
Yeah.
So you only print the class at the ages information. So we may not like it, but you can really print it by student out the print line using the array aspect to string to print out as list. So that is a utility function to help to print out the array. So here does it include array S. So in Java, everything with S means service. So array S is serving for array. There's a class called collections S that also provides service for it. Is that okay? The utility class, so that's wrong. So this time you print out null. First one you print out this, and the next one you print out. You print out the content of the array, but it actually is null. So why does it happen? This happen because right here you declare an array of students, so it's an array of students for 4 elements, that's true. So this one is this as list. It pointing to an array, so this array is student object type. So they are 4, so 0, 1, 2, 3. But they do not put any student there, so they are null. And last time we talked about null variable in pointer means is actually grounded. No student being assigned. So initially, if you create this, there's no student being created yet. Okay. So no student being created. It just created a array. It's just like you build a house or 4-story house. But basically, nobody is living in there. Nobody living in the building. Okay. Nobody living in there, but you do have 4 addresses. You create a building with 4 edges, 4 stories, but nobody. Okay, when you create this, it's nobody. Now we want some people to live in there, so this one we call it declaration. And instantiation. It do create an instance of object, yes, it do, but I'm sorry, it do create the instance of the array. The array do create it, but there is no student associated with. Now, you need to put some student in there, so student 0. You need to create it, so you need to do new student right here. And let's create 4 students. So each student you need to create an object for it. Otherwise, nobody living in the floor. You have 4-story house, but nobody living in there. If you just create an array structure. Now you want to assign different people living in different floors. So this step we call it initialization. Put the initial assignment of the object there. Is it okay? So far? And for this one, you want to print out the data. You can still use this one. You can still use this one. Let's use this one. You put them into the array format to print. Yes. So each one of them will run the toString function for the student. You will run the toString function for the student. Is that okay so far?
Yeah.
Okay. Oh, the student function, we put this extra line or print out the number of students. Let's cancel. Okay, this is called array of students. Now you can also do this. You can also for integer r equals 0, r less than student list, but length I increase. You can also print out your each student by doing this. So at this moment, your 4-story building now leave 4 students in there. Is that okay so far?
Yeah.
Okay, you can also use for each loop. So for each student S from the student list, you print out a student S. Okay. So part 2, assign objects. Okay. Okay, so this tell you what is array of objects. Okay. Can you do this? Can you do like student 2? I don't like the student 2. I actually don't want to assign student 2. Is that okay? That's okay. That's okay, but your student 2 become null now. That just means that your level 2 house, nobody living in there. Is that okay? Is that okay?
Yeah.
So array of object is just like a building. It can be empty, can be occupied. If it is null, that will have what it will not be occupied. So another thing is that right here, if I do this, if I right here, I don't actually do print s, I do get name. Is that okay?
Yeah.
That is okay, but because you may have a house that nobody occupied, then that one is null. If that one is null, you get a null is pointer exception. You got this kind of error. One null pointer exception will happen. Because you try to get the name of a house, there's nobody living in there. Is that okay?
Yeah.
So make sure no null. So one way to do it is that you do this. Okay?
Yeah.
Then that will be okay. If you don't do this, then you are in trouble. Okay? So here you do miss a name, but it's okay, we bypass it. But can we do this? Can we do right here using the equals? Can we do this? Instant, can we do it this way?
No, because then it's no, right?
It's null, but can you do it this way?
No. Because if you're checking if it's null and then like getting the name, then you can't, like, it's gonna be exception, right?
So let's assume that it will happen when you go to the SDs to 2, right? I think 0, 1, 3, they are okay, but you go to 2, is there a equals function?
Oh, right.
No, you don't have that, right?
Yeah.
So you will get this one still will create a null pointer exception. Is that okay?
Yeah.
Just because you do not have that. Okay, you still have the null pointer exception. But if you go to here and you don't have that equals function. But if I right here go to here and then I say, you don't have equals function. But how about this? If I actually provide a equals function, what happen? Will this work?
No, because you're still checking, like, if it's null, it won't be a class. It won't be an object, so it won't have the function.
Yeah. If it's null, there is no object. So this equal function owns only the index 0, 1, and 3 has it. Index 2 still be a null, they still have no equals function. So even you put this, doesn't solve the problem. It's okay?
Yeah.
This one just give you the idea, okay? Give you the test and give you the idea, okay? So very good. That actually is the concept of this, okay? Okay, so this one equals now working. So let's put it back to this. So sometimes people student actually that seems to create a lot of trouble. Sometimes some student may ask that, it's okay to put double equal signs or dot equals or not equals. It really depends where you are and what's the purpose of why you are doing it. Okay, so we cannot just jump to the conclusion that okay, double equal sign is wrong. We cannot say that. It really depends on what are you checking. Okay. In this case right here, checking for equal sign makes sense because you want to detect the null, okay? Okay, just give you the idea of what is array of student. This one, we call it the array of objects. Okay, now this one, let's try another one. Let's try class. let's don't call it class. Class has already been there. Let's call it we call it school class. So a school class may have a teacher, may have a bunch of students. Okay. So here we do have a toString function that will convert your class to a string. So this is single string R. You put a teacher in one line, you put the student in multiple line. Okay. And then you return your R eventually. Okay. So this one called student class. So the difference between this one, student, school class, and test array is like this one test array uses student. Or we call it has student. Okay. So it use student. I'm sorry, it actually primarily use student. So it use student, but student is not their data field. But this school class has student. This class has student. This class use student. Is okay? But both use and has, we all call it has a relationship. Has a student. School class has a student. School class use student. Has array has use student has a student. I'm sorry, this one is use student. Is that okay? Use means you doesn't have it, but you use it. Has means you has it, and you may also use it. Okay? But both has a relationship. Is that okay so far?
Yeah.
Now this one. So this is student class. Now let's create another one. Let's call it as student class. So you still can see I create student, graduate student, school class. And this one tested, this one tested, this one tested. Okay, this is the way we call it OOP. We develop a program not by function, calling function, calling function, calling function. That's traditional structured programming. That's in chapter 1 to 10. Now we are calling about OOP. OOP means that let me write the data first, write me the data first, and then test. Write the data test, write the data test. It's more data centric. When we develop a program, you see, I don't write a big program. I don't write the main program, and the main program call F function call G function call H function. That's called structured programming. But now I'm in OOP. OOP doesn't write it in that way. It's like, let me develop a student class. That's data of students. Let me develop a graduate student class. Let me develop a school class. Let me create the principal class. Let me create a step class. Let me create a library class. And then all this become a school software. Is that okay?
Yeah.
It's different thinking. Linda, is that okay?
Yeah.
And that's what we call paradigm. Structural programming means that you want to develop a program in structure. So if then else, and then for loop, while loop, that's structural programming. Object-oriented programming, let me create an object, create a class, create a subclass, create an object, and then that's who use it, who is who are, and that's actually called object-oriented programming. Okay. And later you may know another one that's called neural network. So neural network, you set up the weight and sum, and then threshold function, and then loop back. And then you have the different with some loop back, different with some loop back, with some loop back, and then eventually you put the whole thing into the GPA for parallel processing. So that's called CUDA. That you solve in neural network format. Okay, so that's called paradigm. You learn C language for the structural programming. You learn C++ and the Java for the object-oriented programming. You learn Python, PyTorch, TensorFlow for the neural network paradigm, functional programming. Okay, so different language give you different idea. That's why I keep emphasize in college, if you go to CS school, you need to learn different language and eventually go to compiler and then go to AI, go to robotics. Okay. Right now, you are still in Java 1 to Java 2. Okay, you are still here. Need time to build up your own experience, okay? Take times. Okay, let's go back to here. This one is test student. Now you have a class of students you want to test. So we may create a string T1 equals you can put this name right here, but you can also do new string. Okay, let's just put teacher right here. Okay, so that's a teacher's name, and you create a student array, student list, equals new student, That's actually copy from the previous example. So that's copy from here to here, okay? This three, that's deleted, okay? So I still keep the number 2 missing because we want to make sure sometimes it may happen that way, okay? So these two, we actually, let's call it preparation of class data. Class data including the teacher and then the student list. Something's wrong. I do not see my cursor. Let me close that in again. So you prepare the data of the teacher's name and you prepare the data for the student list. Now you create student class. Okay, let's call it ECCS 22. A equals new student class. E1. That's list. So you load your teacher to there. You load your student list to there. Let me see something wrong. Student class. What's wrong with it? Unknown type student class. Or school class, I'm sorry. I have a poor memory. Sorry. I named it as a student class, a school class, but I use it as a student class. Okay, anyway, we create a class by loading teacher and loading the student class into the student array into it. And now let's test it. Is that okay?
Yeah.
So basically, let's talk about it one more time. So here you do have primitive data types. So you have integer, double, you have Boolean, you may have a string. String is not primitive data type, but let's consider it very close to primitive data type. Okay, it's a basic data type. Then you build upon to build a student, and based on student, you build student array. Okay, and then based on these two, you build school class. Okay, so these are primitive. Primitive means the basic types, and these are different classes and array. And you start to build your abstract data type. Is that okay? That's how you build up your abstract data types. So it's step by step, you build from the primitive type and then make it bigger, make it bigger, make it bigger. So usually this one, we do not suggest you to go top down. Don't go from the whole class. And then I don't have a student, I create a student. It's actually not the right way. You actually would rather create the data from bottom up, from the smaller data because you want to test it from smaller one and then build a bigger one, and then test the bigger one. So starting from small class, bigger class, bigger class, another bigger class, until the whole system be built. It's called OOP, Object Oriented Programming Paradigm. Is that okay?
Yes.
I'm not just teaching you the technique, but also teaching you the concept, okay? How can you build up a big system? So that's called the so-called array of object and object of arrays. Okay. This one, some student, a school class is object of arrays, object with array. This one, student array is array of object. Array of object is a building. It may have missing items. Okay. How can we do this? So here you have a class called EC22. Let's actually create another one. So this one, you create a new class called ECCS31 Python. Okay. But we change the teacher to Mr. Jiang Dou. But the student is the same. Is that okay? Can we do that? So you have a class, this class teacher is Eric, but the student is 4 students right here. One is missing. Another class teacher is Jiang Dou and is sharing the same class. Is that okay? Everything is okay.
No,
Why not?
because they're sharing the same one.
They share the student, but that's okay.
I'm not sure.
That's okay. So if you have a class, you load the one student list. And then there's a class, you load a different student list, that's fine. But if you want to share the student, that's okay. That means that these two classes are the same student list. This is fine. Okay. But there's a difference though. There's a difference. So this every class they have 4 students. As a call it does assume it's a B, C, D, 4 students. Right, and then you have the Jiang Dou class. You also use the A, B, C, D. So later, for example, like C student drop Jiang Dou class, but maintain in Aries class. This one okay. But if you do share data, what happens? If you do share data, then if the student drop drop, then the two class both got affected. So you like this one or this one? Both are okay. Then it actually related to school policy. Do you allow it to be co-registered in the same class or no? Is that okay?
Yeah.
If you do co-listing, there's an advantage that you modify the student record and both classes will see it. So for example, a student changes his GPA, everyone will see it. Instead of go to there, let me change the GPA for A and A here. If there are 10 classes, then you need to change the GPA for the 10 classes student. Each one's data is different, then you are in big trouble. Okay?
Yeah.
Okay. But there is still a third possibility. Let me talk about third possibility. So that's scenario number one. This one not registered. So number one is like this. Number two, you have this. Number three, there's a third scenario. Third scenario is the class. This one, you have separate student list. But say A students shared by E and J class. They have different array, but they share the object. That actually is fine. B share the B student is fine. But C, every class no C student, but do have C student in J class. D actually you have a shared student. This third scenario, that's okay. So you share by this or share by this or totally not share. There is a deep binding problem. Okay, you have to know how deeply you will bind your data. Okay, so here you do have the student list. That is, okay. So it may be possible to create another one. So this one is a shared class. Share class member, right? But you can also do this. You can also share student, but don't share class. So you can create student as list number two, because new student, still for student. Okay, but you may have school bus class BC CS 42, CPP2, C double class 2, okay? Okay, so this one use a different student list. But it's the student list 0 use student share the same student of the student 0 area from the student list 0 here. And then student list. This one's Daniel. Is okay? So different list, they load some of the shared student into it. So when you load this, there are a lot of same detail you need to take care of. Okay, it's not just straightforward yes or no. You do need to think about which way the data really is. Okay. Okay, so this 3 list. Okay, these two share the data, so no problem. This one take the area from here, take the Daniel from here. Okay. Is that okay so far?
Yeah.
But how about if Daniel changed GPA 3.5, but now it changed to 3.56, sometimes he improved. So this structure, he share in different class, but the GPA, everybody will see it. Everybody see the change. So how the data organized really depending on how the student register the class. Is that okay? So teacher is one part of the class. Student list is another part, but student list, you can have a shared student list or you have individual student list. And even individual student list may also have shared student object because student is a single entity. Student area should only have one record in the whole system. So for example, you are attending, say, Yale University. Your student can only multiply at one location because your area, you are age 18, your GPA 3.8. As long as any one of these change, every class listing should see the change. Every class listing should see the change. Otherwise, you have to maintain the whole area record across the system. It doesn't make sense, okay? It just doesn't make sense. So when you do OOP, you have to take care of who is the subject. What are you talking about here? You talk about student, that's a class of student. You talk about student list, that's an array of student. You talk about a class may involve student and a list. Is that okay? So this like two classes sharing the same list, just like this bunch of students sign up one class and they use a package. So let's assume that it's actually a engineering program. Okay, such as the AI program. This AI program select this group of students, they all take the same class. Then you can put this student, AI student is into the same class. Into the different class. Is that okay?
Yeah.
Hello. So this actually, I just remind you, this actually is all different purpose. Okay, this is called array of object of array. It really depends on where you put your data. Okay, next one is you will load your program, your class file into the Java virtual machine. For example, your static variable, your static function will be loaded when your program got wrong. Then during the runtime, you create object in the heaps, create your local variable in the Java stack. These are local variable. Once they are done, they will be dead. A static variable is always there. This is called Java virtual machine. Okay. So your variable really is like this. When you do have different kind of variable, you may have static variable, you may have non-static variable. So your local variable usually are put into the stack. Okay, so you may have main function that have this variable, and you call your object. So this belong to this main corporate. This part belong to your student constructor corporate. This one belong to your set name friend. So each one, and once you finish the function, you will be pop out. Finish the function, you will be pop out. Okay. While you may have a string name Jiang, and it may be shared by different reference variable. There may be a student reference 23 years old, and then the name is Jiang. So it got shared by different reference variable. Okay, that's how memory allocation will work. Next one, we are going to talk about immutable object and classes. Okay. There are two important immutable object and class you need to know about. One is string. The other one is integer. Actually, double is also an immutable object. Immutable object is something that no change. The data cannot be changed. Okay. So basically, because the data cannot be changed, all private data and no mutator, no setter. So there is a three rule: all private data field, no mutator, and no return of reference type. Three rules. So for example, if you have this one private, that's fine, private is fine. But this one, you have private data field, this one is not good. This one is not good, okay? Because you create a reference type, and this reference type being returned by the public method, and this one create a change that this date can be updated, okay? So three rules you need to remember in your mind. It must be all private data field, no setters. That would be immutable object, and string is one of them, okay? And this reference is talking about current object, okay, current object. Okay. And the next one you need to know about when the class being uploaded and the object. So when you get started, your class will be loaded to Java virtual machine. So load your static member first, your static function, your static variable, constant variable, they got loaded first. Then you start to run your program. You go to your main function, run your program. Then your instance variable got created. Okay. So these are the order of what variable being created. Okay, so far, okay. Any questions so far?
No.
And then this one is a complete class writing style. You need to follow. Usually put your constant on top, and then instance variable, and then constructor, and then setter mutator, and then your toString function, and then your main program or other static function. Is that okay? This one just a guideline. That means that you have to. It's not a law. So if you don't follow it, you won't create trouble. It won't. It still pass the compiler. Okay. But usually this one is a good design convention. It's not syntax. Okay. So here are more detail. I don't want to go through it too much. Okay. Okay, this object class, remember last time I'll come back to here. Okay, we are already too late. Some students lose patience. So next week we will start from this object class and beyond. Okay. This chapter a little bit too long so far because it has 134, 140 slices. We are up to 106. Okay. You can work on the homework, no problem. Okay. But we'll resume starting from this 106 this time. Okay. It is really a long chapter. Okay. Any questions so
Dr.
far?
Zhao?
Yeah.
Will like the homework like every week still have like more, or is it like based on the class, not like based on like what is it like, the graph you post?
Finish the whole chapter if you can.
Okay.
Yeah. If you have question, you can still ask. This different remaining one, just because we don't have the time, that is not really that hard. You can try. Okay. Any other question? Any other question?
No.
No, if no, that's it for today. Okay, keep working hard. Everyone are good. So far, I would say we already maybe 2/3 into the APCSA exam already. Okay, we will finish up this pretty soon. Only September and October we will finish up the whole course. Okay, we are almost 2/3 in the middle of the class. Maybe a little bit over half going to 2/3. Okay. But this portion is the most crucial one. You have to remember that, and then your foundation for coding will be good. Okay. Okay. Good night, and see you next time. Bye bye.
Bye.
Thank
Thank
you.
you.
Thank you.